Hello and good evening. What is the most important thing in an RF lab? Now, a lot of people will say, well, it's a test equipment, network analyzer, spectrum analyzer, maybe others will say the software you're using, simulation software. But what's almost always overlooked and often is neglected in in a lot of RF labs, and especially if it's in smaller companies or in a hobby environment, or the RF cables and adapters. But actually, I can't argue that the RF cables and adapters that you're using are much more important and play a much more crucial role than the test and measurement equipment that you are using. And I've seen a lot of cases over the years where a bad cable or a bad adapter can very easily set you back days or sometimes even months because you took measurements that are not valid and that are bad. And in even worst case scenarios, a bad cable or adapter can even damage your device on the test, and then can hurt your schedule and your budget. So it's always important to pay attention. What are you using in terms of cables and adapters and other test accessories? So as for myself, I'm made it a habit to buy new cable assemblies, even though there are a lot of cable assemblies available on the used equipment market, and especially on eBay. You simply never know what you're gonna get. You don't know what kind of life you still have left in a cable assembly. And even if a cable assembly you buy on eBay looks good on the outside, it might have been subjected to temperature cycling or other test procedures that degraded the performance or even damaged the cable. And so the cable still looks good on the outside, but electrically the performance sucks. So I found those cables that I'm showing here right now on eBay. They were sold as new assemblies. They came still in original packaging, so confidence levels that they are indeed new is very high. And they also still have the protective caps on the end. And the seller only charged about $50, so I figured, okay, well, it's a good price. Those cables normally cost about $250-$300 a piece if you buy them. Those assemblies here in the picture are 20 centimeters long, which is, for reference, 1 foot is 3 foot represents about 1 meter. So those cable assemblies are roughly about a foot in length, which makes them nice for some bench tests. If you have a network analyzer on the bench and want to connect the device on the test and don't want to mess around with long cables. But those Sooner assemblies are really fairly nice cable assemblies, and some people, or a lot of people here over here in the United States, are not as familiar with Sooner, because Sooner, of course, being a Swiss company, and with the United States, Gore is kind of well known. But Sooner actually makes pretty nice cables, and I've been using them for years. Now, those particular assemblies right here, they are Sooner 100 series, and this assembly right here basically is a Sooner 102 series cable. What makes them nice is the fact that they have a very, very small diameter, so they are easy to handle. They're not too heavy, especially if you work with probe stations. They are nice because they don't pull a lot on your probes or don't put a lot of stress on them. But what's also nice is that basically those cables if you bend them, you see like what I did here, and they stay in place. So sometimes what's annoying, if you make a test setup on your bench and you have a board or something on the bench, and you've seen it often that the cable kind of pulls your device on the test around because the cable wants to go in a different direction, and well, of course you can fixate your device on the test, but still those cables don't do that. They stay in place wherever you put them, and that makes them nice. So now the next question you might ask is, okay, what about the performance of those cables? Because they are so small, are they good cables for the insertion loss typically? What kind of power handling can I expect? How far in frequency do they go? Now, the cable materials that's used on the 102 cables is specified to work or guaranteed to work to 46 gigahertz. Of course, those assemblies right now here have SMA connectors on them, and that kind of limits the frequency range of the assembly to 26.5 gigahertz, because it's what a good SMA connector normally can do. But I mean, I would be surprised if you could push them a little bit higher, probably to 30 gigahertz. But I'm not sure if you can get 40 gigahertz out of them. So for reasonable performance, I would say 26.5 is reasonable to expect. So I'm taking a look here at the data sheet, and you have the nominal attenuation specified in dB per foot and dB per meter, and then also the maximum CW power handling. So as you can see, for at 2 and 3 gigahertz, you can expect about 0.58 dB per meter or 0.17 dB per foot. So at an upper 18 gigahertz, it's 1.72 or 0.624, and 26.5, it's not specified. It's specified at 27, so it's 2.14 or 0.652. So basically, for those assemblies right here, you can expect about 0.6, 0.7 dB at 27 gigahertz and 0.17 dB at 2 or 3 gigahertz. So they're not really low loss cables, but they are nice, they are reasonable. Insertion loss, they are not too high, and so that makes them good. They're good bench test cables that you can use. But what about power handling? I mean, obviously with the cables, it's so small. What can you expect? And they really surprise you here with the power handling as well, because 2 gigahertz they're specified at 260 watts, and up at 10 gigahertz, it's 10 gigahertz band, it's still 116 watts, and it's at sea level and 40 degrees ambient temperature. So yeah, it's fairly decent power handling. I mean, you can't hook up your 1 kilowatt power amplifier, but given that in most amateur radio settings, if you can get 50 watts at 10 gigahertz, and you're good. So those cables pretty much cover every situation that you can encounter. But like I said, once you get to higher power levels, then you should use a different assembly. But then of course it's the limitation is also of course the SMA connector, and for most high power amplifiers that go into the 500 watt range or 1 kilowatt range, you mostly use N-type connectors or anything else but SMA anyway. So I would say those cables, they are a great addition to any lab for general bench testing, for power amplifiers up to 250 watts, and fairly low loss cables. You can get them at a decent price on eBay right now for $50. Like I said, regularly Mauser charges about 260 or 300 for a cable. So yeah, I mean, they're not good phase flex, but for your daily lab testing, they work just fine. They're great additions. They're nice cables, and I would absolutely recommend for any lab to have a couple of them around for general purpose testing, bench testing. So that's it for right now. Thank you for watching, and please like my video and share it if you enjoyed it, and I see you later. Bye.